In today's lesson, we're looking at 3.3, the slopes of lines. Slope is something that we use all the time in science, and you've used it quite a bit in algebra previously. So first, a review over lesson 2. Here we're told that the measure of angle 4 is 146, and we need to find the measure of angle 2. Well, 2 is a corresponding angle to angle 4, so its measure is also 146. Okay, this measure of angle 4 is still 146. We need to find the measure of angle 7. Okay, alternate angles, such as these, are not corresponding, but we do know that angle 2 and angle 7 are supplementary. They're a linear pair. And we previously determined that angle 2 was 146 when 4 was. So if 2 is 146 and it's supplementary to 7, that means that 7 is 180 minus 146, or 34. Okay, angle 4 is still 146. We need to find the measure of angle 10. Well, we can do that in a few different ways. 4 is a corresponding angle to 2. We know that their measures are equal. They're congruent. 2 is also a corresponding angle to angle 10. So it is congruent, and their measures are equal. So in this case, angles 4, angle 2, and angle 10 all measure 146. Okay, angle 4 is still 146. What is the measure of angle 11? Well, 12 is a corresponding angle to angle 4. So angle 12 here is 146. It is supplementary to 11. So angle 11 is 180 subtract 146, or 34. Find the measure of angle 11 and angle 16. Okay, so if we start here at the 146, we know that 12 was 146 and this was 34. Okay, 12 is the same measure as 10. They're congruent because they're corresponding angles. That means that angle 10 is 146. And if angle 10 is 146, 16 is a vertical angle, so 16 is also 146. So angle 11 and angle 16 together make up 180. Okay, in the map shown, we have 5th Street and 7th Street. They are parallel. At what acute angle do Straight and Oak Avenue meet? So Straight and Oak are transversals of 5th and 7th Street. We know that this angle here is 75 and that this angle here is 53. We need to know the angle at which Straight and Oak Avenue meet, which is this angle right here. Okay, if this is 75 here, our alternate interior angle is congruent, which is this angle right here. If this is 75 and this is 53, The three angles all together have to equal 180. 180, subtract 75, subtract 53, and you are left with 52. Okay, so in our last lesson, we used the properties of parallel lines to determine a variety of congruent angles. What we're doing in this lesson is finding the slopes of lines and using the slope to identify whether lines are parallel or perpendicular. So we're looking once again at slope, that rise over run of a line. And that slope will also indicate a rate of change. So if we have a coordinate plane, such as this grid with an x-axis and a y-axis, the slope of the line is the ratio of the change along the y-axis to the change along the x-axis between any 2 points in the line. So they give a formula here that m, which stands for the slope, is equal to y2 minus y1 divided by x2 minus x1. Okay, obviously x cannot be equal. We can't have x1 and x2 equal where we have an overall value of 0. But we need some actual real numbers here. Find the slope of this line. Okay, so remember that we had that formula that m is equal to y2 minus y1 over x2 minus x1. So with this point right here, we know that this is x1, y1, and this point here is given by x2, y2. Okay, those are the coordinates of those 2 points. We're going to substitute in for x1, y1, -3, that's 1, 2, 3, and I go up 7. My second point, point T, is at -1, -1. So we put that into the slope formula. Okay, so that means that this y2 comes right here. My y1 comes right there. And then we bring the x's down. -1 subtract 7. -1 subtract -3. Remember that whenever we're subtracting a negative, that acts as adding. And we end up with -8 divided by 2, or when we simplify, -4. Okay, a negative slope indicates that the line is trending downward. Find the slope of this line. Okay, we're still using the same equation. For our point G, which is point 1, I see that we have coordinates of -2 and -5. And our point 2 here at F is at +6 and +2. Okay, substitute those numbers into the slope formula. 2 subtract -5. And 6 subtract -2. We have 7/8. This is a positive slope, indicating that the line is trending upwards. What happens if we have no slope? No slope means a horizontal line. Find the slope of this line. Okay, we have for point P 0 and positive 4. And for point Q, 0, negative 3. Substitute that into our formula. We get negative 3, subtract 4, and 0 divided by 0 subtract 0. We have an error. With 0 subtract 0, our slope formula doesn't work. The slope is undefined. Your calculator has an issue with dividing by 0. Find the slope of this line. Now, we talked about this a couple slides ago. If we have a horizontal line, we have no change in y. We'll end up with 0 divided by some number. Regardless of the points, we end up with 0 divided by 8, or simply 0. There is no slope. Okay, find the slope of this line. Okay, we need to plug this into the equation. M is equal to y2 minus y1 divided by x2 minus x1. That means I have 1 subtract 4 on my y's and 2 subtract negative 3. 1 subtract 4 is negative 3. 2 subtract negative 3 is 2 plus 3, or 5. So our answer should be C, negative 3/5. Find the slope of this line. Well, this one, we don't even really have to do the math. We see that if we have y is equal to y2 minus y1 over x2 minus x1, that already this portion is 0. We have no change in the y. Since we have 0 divided by the number of the change in x, we already know that, hey, horizontal lines have 0 slope. Find the slope of this line. Okay, plug it in. y2 minus y1. x2 subtract x1. 2 subtract negative 4 is 6. 5 subtract 2 is 3. Simplify. Our slope is simply positive 2. What's the slope of this line? Remember that our slope is our change in y over our change in x. Well, we have no change in x position. This is already 0. I can't divide by 0. My calculator can't do that. This is undefined. Vertical lines where there's no change in x is undefined. So if I have things moving upwards and to the right, I have a positive slope. If I see it downwards to the right, it's a negative slope. If I see no change in y, it has 0 slope. And if I have a vertical line, I have an undefined slope. I can't divide by 0. So let's look at using the slope to determine the rate of change. In the year 2000, the annual sales for one manufacturer of camping equipment was $48.9 million. In 2005, the same annual sales were $85.9 million. If the sales increase at the same rate, what will be the total sales in 2015? So we can see that we have a difference of years and a difference of annual sales in dollars. So we need to analyze the situation. Okay. And the first thing that they do is they use this data to create a graph. So they start at year 2000. Okay, and that's where that y-axis begins. They show that at the y-axis, at the year 2000, that the sales was 48.9, very close to 50 million in the annual sales on our y-axis. Okay, 5 years further on, at 2005, the sales have increased to 85.9. Now, to determine what things are going to be like in 2015, which is going to be 15 years since the year 2000, if it follows that exact same line, that same trend, we can calculate this by determining the slope. Okay, or also by looking at our graph. So I'm expecting from the graph that at 15 years, it's going to be somewhere around 145 million. Okay, because that's where that would cross and meet at that line, about 145. So let's find the slope of the line. We need the change in y divided by the change in x. Change in y was 85.9, really 85.9 million. Subtract 48.9 million. Okay, millions of dollars is really our unit here. And the change in years was 5. 5 subtracts 0. So when we do the math, the slope of that line is 7.4. Okay, so knowing that slope, I can determine what things are going to be like in 2015. Each year, it's increased by 7.4 million. Okay, use the slope of the line and the one known point on that line to calculate the sales y when the years x since 2000 is 15. Okay, so we have our slope formula. We put in 7.4 for the m, and we know that we have a change of 15 years, and we know the original value of sales. So now I can solve for that y2. Okay, so when I simplify this just slightly, I see that 7.4 is equal to y2, subtract 48.9, divided by 15. Okay, multiply both sides by 15. And then I'm going to add 48.9 to both sides. And it shows that our sales are 159.9. 159.9 million. Now, did that work with what we saw on the graph? Let's take a look back. And so I feel like I predicted something a little bit different. Okay, 15 years since. Oh, I was on the wrong side of this line. I was looking at year 13. At year 15 would be here, and yes, that would be above the 150, be somewhere in there. Okay, so using that slope that you've determined from the first 2 points, I can substitute in that slope and 1 point with the known information to determine our answer. Between 1994 and 2000, the number of cellular telephone subscribers increased by an average of 14.2 million per year. In the year 2000, the total subscribers was 109.5. If the number of subscribers increases at the same rate, how many subscribers will there be in 2010? Okay, so we have a rate of increase. That rate of increase right here, 14.2 million per year, is our slope. Okay, we have a particular point where we have our year and we have our amount of sales our number of total subscribers, and we're trying to determine our new number of subscribers. So this is like X1, Y1. This is, X2, and we need to determine the Y2. So we have M is equal to Y2 minus Y1 over X2 minus X1. We know that our rate was 14.2 million per year. We know that our Y2 is what we're trying to find. Our Y1 is 109.5. And our X2 is 2010. And our initial one was 2000. Okay, so I can do the subtraction here and find out that this is really 10. If I multiply this side by 10 and this side by 10, I would have 142, now equal to Y2 subtract 109.5. So my Y2 is equal to this 142 subtract 109.5. Okay. And we determined that we have new subscribers 10 years later, where we've increased by 14.2 million per year to be 251.5 million. Okay, we have some additional postulates, 3.2 and 3.3. Both of these have to do with slopes of lines. 3.2 is about the slope of parallel lines, and 3.3 is about the slope of perpendicular lines. If we have two non-vertical lines and they have the same slope, they will have the same slope if and only if they are parallel. And all vertical lines are parallel. In the case of perpendicular lines, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. If I take those two slopes of the two lines and they, when they're multiplied together, equal -1, they are perpendicular. So let's determine whether line FG and HJ are parallel, or whether they're perpendicular, or if they're neither. And we need to graph each line to verify our answer. So this is something where it's very helpful to have a ruler and have some paper. Okay, I'm going to try to show you here on the screen. First off, find the slopes. Okay, those slopes will definitely help. Okay, FG, we need to compare the points for F and G. So we have M is equal to Y2 minus Y1 divided by X2 minus X1. So that's -1 subtract -3 and -2 subtract 1. When we simplify that out, we find that to be -2/3. Okay, for HJ, we have 3 subtract 0 and 6 subtract 5. So that is 3 divided by 1, or 3. So is there any relationship between those two lines? Okay, the slopes are not the same. So since they're not the same, they can't be parallel. And the product of the slopes, if we multiply those slopes together, we get a -2. So they're not perpendicular either. These are neither parallel nor perpendicular. When graphed, we can see that they intersect. They do not intersect at a right angle, and they're certainly not parallel. Okay, determine whether these two lines, AB and CD, are parallel, perpendicular, or neither. Okay, so we're going to do the same thing. Remember that slope is y2 minus y1 divided by x2 minus x1. So for AB, that's going to be, let's see, 5 subtract -1, and we have 4 subtract -2. 5 plus 1 is 6. 4 plus 2 is 6. So the slope of AB is 1. And if we look at CD, we have -2 subtract 1. And 9 subtract 6. So that's -3 over 3, which is -1. Okay? So we have 1 for AB as the slope, and -1 for CD as the slope. They're not the same, so they can't be parallel. Okay, their slopes are different from one another. But if I multiply those slopes and take the product, 1 times -1 is equal to -1. And so it is perpendicular. Okay, so now we can use the slope to graph a line. We have a line that contains a point Q, and it's parallel to MN. Okay, MN has the points -2, 4, and 2, 1. First, we have to find the slope of line MN. So we use the slope formula and substitute in the values for the points. 1 subtract 4, 2 subtract -2, and we simplify that to be -3/4. Okay, so that slope is needed with point Q. Okay, because the slope of two parallel lines is the same. So this is the slope of our new line. The line parallel to MN through point Q will have a slope of -3/4. So now we can graph that line. Okay, here was the initial line MN. Point Q is at 5, 1. To have something parallel is going to be an equal distance from MN. So I can start at 5, 1 and move up 3 units and then move to the left, the negative x direction by 4. And we label that as another point in the line. We could call that point R and draw our line through there. So QR is a new line that is parallel to MN through the point Q at 5, 1. Okay. We need to find which graph contains point R at 2, 1. Sorry, 2, negative 1. Okay, so we can start looking for that. And is parallel to line OP with points O at 1, 6 and P at negative 3, 1. So if I look to see which contains an R at 2, negative 1, okay, I can see already that this is at 2, negative 1, this is at 2, negative 1, but D is not. Okay, R is in the wrong location. Okay, but this one is a possibility and this one's a possibility because of their location for R. Now we need to determine the slope. Okay, the slope of OP is going to be 1 subtract 6 and negative 3 subtract 1. One subtract 6 is negative 5. Negative 3 is negative 1. So we end up with a positive 5/4. So we need something that is increasing in the y direction and increasing in the x direction. So here, if we have P at negative 3, positive 1, that seems to match here. So these 2 points are matching. If I go up by 5, 1, 2, 3, 4, 5, and I go over by 4, I reach O. So that seems to match this here, and I can see that this is parallel. I go up by 5, 1, 2, 3, 4, 5, and then over by 4, and I reach this point S. This is our correct choice. And you're ready for your homework for 3-3.